Welcome back from lunch, everybody. Hope you found something good to eat out there. Once again, my name is Quentin Zondervan. I'm the president of Green Cambridge, one of the co-sponsors of this event. And you'll notice I don't use PowerPoint because I'm actually a software engineer. So we'll leave it at that. One of the things that Green Cambridge does is we help install rain barrels in the community for free as a community service. And I knew that that was a good thing, but I didn't actually know until recently how good a thing it was until I attended the 24th Susterapalooza at the EPA in Boston, which is a conference about seagrass. And you're going to hear a lot more about that from the next speaker. But the thing that was really amazing to me was how I've been living in the Boston area for 20 years, and I'd never heard of this conference. So we are creating monocultures in our human ecology where we don't know about each other. We don't know about the work that's going on. The people who went to that conference are all scientists, and they're experts on seagrass and how seagrass can help us sequester carbon. The people I hang out with all the time are activists who are screaming, we need to do something about climate change. But we're not talking to each other. So I'm glad that we're here today and that we are talking to each other, and we need to do more of that. So with that, let me introduce you to Phil, who's going to tell us more about seagrass.
You can tell the marine biologist in the crowd, he's the one with the fish shirt on. Okay, my name is Phil Colarusso. I'm a marine biologist with EPA, and a disclaimer, all the thoughts in this talk are mine and not necessarily official agency position. So especially when I tell you how to live your lives at the end of this talk, you'll understand this disclaimer. Okay, so blue carbon, what is it and why should you care about it? Normally when I give these talks, I have to explain climate change and why we should worry about things like that. I don't think I have to do that here, which is good, so we'll just start right in with blue carbon. Okay, blue carbon is the carbon that's associated with salt marsh, seagrass, and mangroves. And why just those three marine habitats? Because those species sequester, and as a member of a federal agency, I use the word sequester with a lot of trepidation. But in this case, it's a good thing. They actually sequester carbon. So macroalgae, phytoplankton, other marine plants that actually use carbon don't sequester it, they'll recycle it. So it's not necessarily a net gain in the carbon cycle. Species that in these groups also have high growth rates, and thus they absorb large quantities of CO2. And as previous speakers mentioned, the carbon is sequestered primarily in the sediments in the soils. And they will stay there for as long as these habitats stay intact, which is really one of the key points of my talk is the conservation of these habitats because they're storing a lot of carbon. Now, you're going to get a bunch of my vacation slides. This is mangrove from the Cayman Islands, and the neat things about these plants is, you know, they have the extensive root system, and if you're a diver like me, you like to approach the plants from the other side, and you can see the roots sticking into the water, and there's a lot of juvenile fish that use that habitat, reef species that start their lives in and among the roots of this particular species. This is Thompson Island in Boston Harbor, and the extensive salt marsh there, and you can just imagine the amount of biomass that's associated with that marsh. And if you think about the rich peat, think about all the carbon that's stored in that peat over time. And this is the habitat that I'm more familiar with. This is Zostra marina, or eelgrass, which is our local seagrass species. This was taken in Fairhaven, Mass, but if you're interested in seeing a local population, the next time you fly out of Logan on runway 22, which is the one that points towards Deer Island, look down into the water. The largest meadow in Boston Harbor is at the end of runway 22. It's about 50 acres of eelgrass. And this is what that meadow looks like when you sample it. Nice, dark, green, rich, lush, very productive habitat. So exactly how good are these habitats at sequestering carbon? Well, as a marine biologist, I'm used to dealing with like milligrams per liter, parts per million, parts per billion. It took me a while to make the conversion to megagrams of CO2 equivalents per hectare per year. That's several orders of magnitude much larger than I'm used to dealing with. But so mangroves, salt marsh, and seagrass. A couple of things to take away from this this slide. The numbers vary dramatically. Some of it is the studies are using different techniques, different species, different time of the year. For seagrass, it can actually be a carbon source, and I'll talk about why in a minute. The other thing is compare these habitats to tropical rainforests, which are what people think of as really good carbon sinks. Rainforests, I think, recycle a lot of their carbon, and again, these habitats are sequestering a lot. So seagrass has a very dramatic range, and it can be negative at times. And the reason that happens is if we're degrading, particularly water quality, that habitat is degrading, and it ends up releasing a lot of the carbon that has been stored in those sediments for hundreds, if not thousands of years. And so that's why it becomes a source. I feel like I have to put this slide in every talk I give about seagrass. And it sounds like the people in this audience would appreciate a little of the basic biology. But it grows like the grass in your front yard. It has a long lateral rhizome with associated roots. And these rhizomes can be literally hundreds of meters long and live. They've been carbon dated, not for Zostra marina, this species, but for another seagrass species. It's been carbon dated for a 1,000-year lifespan. They put out lateral shoots, and the upright shoots can grow. Typically in Boston Harbor, we find plants that are about 3.5 feet in height at the peak of the growing season. I've pulled a 9-foot plant out of the Piscataqua River in New Hampshire. So they can grow dramatic. There's a fair amount of phenotypic plasticity on how the phenology of the plant actually grows. It adapts to its environment. If you find it in very shallow water, it obviously won't grow that tall. It will stay fairly short. But in deeper water, it can grow to impressive heights. All right, so what is why do we care? What's the importance of seagrass? And I'm just talking, normally when I give seagrass talks, I list the litany of wonderful things that seagrasses do: fish habitat, nursery habitat for invertebrates, bay scallop habitat, but we're just talking about carbon here. And seagrass meadows grow in a very narrow band along our coastline. They're shallow water plants. So they only occupy about 0.2% of the area of the world's oceans. But they account for 20% of the sequestered carbon on an annual basis. So they're disproportionately important to the carbon balance of our seas. All right, so loss and degradation of these coastal wetlands. Mangroves, we're globally losing about 0.66% per year. Most of that, or a lot of that, has occurred in Southeast Asia, where shrimp farming is very prevalent. So what happens is people will impound large areas. They'll dig out the mangroves and create impoundments. And I have a photo I'll show you later where they actually farm shrimp. So a lot of the shrimp you're getting in the supermarket right now, if it's from Thailand, Cambodia, Vietnam, it's from these shrimp farms. Salt marsh, we don't have a lot of areas of we don't have good data for in different parts of the globe, but it's estimated we're losing about 1 to 2% per year. And with sea level rise, it's thought that that percentage will actually increase. And seagrass globally, we're losing about 1 to 3% per year. So what do all these losses mean, and why am I telling you all this? Well, putting these losses in some kind of context, carbon context, the emissions that result from the conversion and degradation of just the wetlands is estimated to be somewhere between 300 to 900 million tons of CO2 equivalents per year. So what does that mean? Well, that's roughly equivalent to the annual emissions from the energy and industry sectors of Poland and Germany. And recently, and I don't know if this is absolutely true, but recently someone told me that all of NOAA's climate forecasts, future forecasts, do not include this source. They're just looking at emissions. They're not looking at conversion and degradation of wetlands loss in their future estimates for climate change. All right, so this is stolen from a Greenpeace website, and these are the shrimp farms, what they look like. These impoundments, they grow shrimp for a couple of years, then the impoundments become degraded, and they move on to the next one, and they never really repopulate with mangrove. This is Rumney Marsh up in Saugus, Revere, Lynn area. And this is about everything you could probably possibly do wrong to a salt marsh. There's a landfill here, commuter rail line that I ride goes through the marsh. You have people building on the backside of the barrier beach, which used to be all marsh here. This is GE Lynn, so you have an industrial complex. And if you look closely, you can see that the entire marsh has also been diked for mosquito control. This I like to call people doing stupid things in boats. This is Billingsgate Shoal in Cape Cod Bay. If you look very carefully, you can see these lines, which are basically prop scars from people going around in circles or cutting out of the channel and basically uprooting or impacting the seagrass. This, I wish I could take credit for this slide. My wife put this in one of my talks unexpectedly. I was giving at a conference with the full audio of Sheryl Crow, Soak Up the Sun. If you take nothing else home from this, seagrass needs light, 20 to 25% of the ambient light, much higher than other marine plants. So anything you do that degrades water clarity in particular is a bad thing for seagrass. And so we'll talk a little bit about the stressors. All the stuff that you guys were talking about this morning, the stuff I work on is all downstream from you. And so when people are talking about fertilizer-free agriculture, I was very happy to hear that. Because the stuff that I deal with the tail end of the pipe. So I'm concerned about elevated levels of nitrogen in the ocean, causing eutrophication, water clarity problems, and reductions in this vegetation. We also deal with pier and wharf and moorings. So seagrass tends to grow in areas where it's quiescent. Also areas where people like to put their boats for the same reason. It's protected. Dredging, we need to keep our navigational channels open, and that usually has bad implications for seagrass. Invasive species, green crabs, tunicates, other things impact our native populations. Trawling and shellfishing also have potential negative impacts. So now we get to how I tell you to live your life. Reduce nitrogen. That's the best thing you can do for these plants. Cut fertilizer use, eat lower on the food chain, use mass transit. I know that I ride the commuter rail. I know it's a pain, especially this winter. Limit, if you're doing any kind of construction or expansion, limit or reduce impervious surface, the rain barrels, One of the biggest things we deal with now is non-point source nitrogen getting into our coastal waters, and it's really controlling lots of small sources. We're doing a fairly good job on sewage treatment plants, which are the large point sources, but chasing all these small non-point source is hard, and we need everyone to participate. All right, this is the part where EPA would probably kill me. Avoid farm shrimp. That's my personal bias, not necessarily an agency position. Be a responsible boater. You know, there are other things in the ocean besides your boat. And then I throw this in. Unless we want our polar bears to be Diane Naiad type swimmers, we need to remember that everything's connected. So thank you.